The answer is 21. 3 sevens, 1, 2, 3, and 7 threes both land on 21. Why on earth would you want to draw it to figure it out? 3 sevens and 7 threes is the same number. Now we can establish a pattern to avoid drawing the Lewis dot diagram. So we're trying to find a way around giant diagrams if possible. This is called the crossover method. We write out titanium and nitrogen next to each other. 7 electrons to give, we'll only have room for 3. And we just cross the numbers over and we'll bring them down. 3 sevens is the same as 7 threes. We have our answer. Just do not blindly use this. It can trip you up. Molybdenum nitride. I don't know what it's for, who uses it, but we can form it. It probably has a use, but I'm just using this as an example. I got other things to teach you about cool chemistry that you see every day. Using the crossover method, you would come up with 3 molybdenums and 6 nitrogens would give you the balance. But you've actually overshot. You didn't need as many as that. Watch. If you drew it, molybdenum with 6 and nitrogen with 2 works out just fine. What we wound up doing is jumping to a multiple of the answer. I can illustrate this even better this way. You use the crossover method, but you think. I'm inventing 2 imaginary elements. Element A, whose valence is plus 12, element B, whose valence is minus 4. The crossover method would have you make 4 A's and 12 B's. But just like in math class, you're looking at a fraction that can be reduced. If I say you get paid $4 for every $12 your friend gets paid, there's a way to reduce that to a smaller ratio. Common denominator is 4. So if you divide both of them by 4, you realize it's a 1-to-3 ratio. You didn't need to use 4 to 12 when you could reduce it. So if you use the crossover method and you get a multiple, you take it, cross it over, and if that's reducible, do so. You really aren't going to see that. We're not really going into that kind of detail, but that's all it takes to use the method to balance 3s and 2s and the other odd to even splits.